Good morning, friends, and welcome to another class. In today's class, we're going to be looking at the groups and the periods of the periodic table. So, I remember in previous lessons, we looked at the periodic table and we said something about the groups and the periods. And I remember we looked at the simplified version of the periodic table, and that was this one. So, this was the simplified version of the periodic table we looked at. Now, whilst we were looking at that, we said something about group. And I remember we said that the groups refer to the vertical arrangement of elements. So when you look at the elements from hydrogen, lithium, sodium, potassium, and rubidium, that vertical arrangement will be a group. And in this case, the group 1. Then we also have another group: beryllium, magnesium, calcium, and strontium. That's another group. Is group 3. So the vertical arrangement of elements on the periodic table refers to the group. We said something about period. And for period, we said that it is the horizontal arrangement of elements. So in this example, you can have from lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So that horizontal arrangement is what we call period. In this case, we are in period 2, from lithium to neon. And you can even have another period from sodium to argon. So sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon will be another period. So in this case, it's period 3. Now, what we are looking at today is, why would you have some element in the same group? And why will you have some elements in the same period? So that's basically what we are going to look at. Start with why we have some elements in the same group first, then afterwards we look at why we have elements in the same period. Now, but before we even delve into that, let me find out from you. In school, why would teachers put you in the same group? And the simple reason for that is that you are in the same group because you have something in common with those other members of that group. So basically, that's the reason why you are in the same group. Honestly, the same thing applies here. The reason why hydrogen, lithium, sodium, potassium, and rubidium are in the same group is because of something that they have in common. And that's what we are going to find out about today. So here, let's just take three of the elements in that group, group 1: lithium, sodium, and potassium. Then we look at them and find out what they have in common. So let's take lithium, sodium, and potassium. Now, for lithium, you know the atomic number is 3, so let's just write it by it. It's 3. Sodium has atomic number of 11, so let's write it by it. Then potassium has atomic number of 19. Let's write it by it. Now, I'll need us to come up with the electronic configurations of these elements. So for lithium, it will be 2, 1. That's the electronic configuration of lithium. For sodium, it will be 2, 8, and 1. Then for potassium, its electronic configuration will be 2, 8, 8, and 1. I believe you've not forgotten about the electronic configuration, how it can be written. Please, if you've forgotten, then you need to refer to our video on electronic configuration. So these are the electronic configurations of the elements. So for lithium, you have this. For sodium, you have that. For potassium, you have this. Now, the question is, what do these electronic configurations have in common? When you look at the last shell of the electronic configuration, you realize that they all have electrons of 1, 1, 1. So that's what they have in common. So we go into the last shell of the element in the same group of 1 and realize that they all have valence electron of 1. Now what this means is that The valence electrons of element determines their group number. And it's amazing how the valence electron of one matches with the group number of one. So you see group one element have valence electron of one. So what it means is that if you are in group two elements, or if you are dealing with group two elements, all of them would have valence electron of two. The same applies to group three elements. Element in group three, all of them have valence electron of. And please, those of us who do not understand the term valence electron, you need to refer to our video on valences. And that's simply the number of electrons in the last shell. That's the valence electron. Okay. So that's what you need to know about why you would have to put the same elements or different elements in the same group because they have the same number of valence electrons. Now there's this other thing we need to remember. Normally the valence electrons of element determines their chemical properties. So the reason uh, an element will react in a particular way is because of the valence electron. So what it also means is that if elements have the same valence electrons, they would have to behave the same way chemically because valence electron determines their chemical behavior. So clearly what this indicates is that elements in the same group have the same chemical property. You need to remember that. But first note that the valence electron determines the group of elements. Then you need to also remember that because they are in the same group and they have the same valence electrons, they behave the same way chemically. So that's all you need to know about groups and what will make elements to be in the same group. Let's quickly go to the period. We're going back to the electronic configuration, sorry, the periodic table. So that's the periodic table. So this time we're going to look at period. Let's maybe take the period 2 or let's take period 3. So period 3. So in this period, you have the elements sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. The question is, what do they also have in common? Why are they in the same period? So that's what we are going to find out about now. So here to take three elements, we take magnesium, you can also take silicon, then maybe take sulfur. So let's take magnesium, silicon, and sulfur. So magnesium, silicon, and sulfur. Let's write the electronic configuration of these three elements. But let's remember that magnesium atomic number is 12. So silicon is 14, while sulfur is 16. So quickly, we are going to write the electronic configuration of these elements. So magnesium will be 2, 8, 2. So that's magnesium. Silicon will be 2, 8, 4. That's silicon. Then we have sulfur. It will be 2, 8, 6. So write the configuration of sulfur. Now, what do these elements have in common? Observe this carefully and see if you can find out what they have in common. Well, let's quickly jump into this. When you take magnesium, how many shells does magnesium have? It has three shells. So that's the first shell, the second shell, and the third shell. What about silicon? It also has three shells. That's the first shell, second shell, and third shell. What about sulfur? It has three shells, first shell, second shell, and third shell. It's amazing that they also are in the same period number 3. The period in which they are is period 3. So can you think carefully about why the coincidence? It's simply because the period the of the periodic of the element is determined by the number of shells. So elements of the same number of shells are in the same period. So if you have 4 elements and all of them have shell of, let's say, two shells each, what it simply means is that they are in the same period of 2. So that's how this is done. So it also means that, let me give you another example. Elements with, let's say, 5 shells would also be in period of 5, because the number of shells determines the period number of the element. Please, I need you to remember this. But the other thing you need to remember about periods is that elements in the same period have the same physical properties. Please remember, physical properties are not the same chemical properties. Chemical properties simply refers to how the elements react, while physical properties simply refers to the way they behave, I mean the way they look. For example, let's say their texture or their state, whether liquid or solid or gas. So those are physical properties. So elements in the same period have the same physical property. So if one element is, let's say, solid, all of them would also be solid. Well, of course, there are instances when you would have exceptions, but that's generally what you need to remember. Generally, elements in the same period have the same physical property. So, guys, that brings us to the end. Will bring us to the end of today's lesson. But let's quickly summarize everything we have learned. So, we've said that for group elements in the same group have the same what? They have the same valence electron. Okay? And as a result of that, they behave the same way chemically. Please remember these two items. So they have the same valence electrons and they behave the same way chemically. What about periods? Now, elements in the same period have the same number of shells. Alright, and because of this, they have the same physical properties. This is the takeaway point for today's lesson. That brings us to the end of today's lesson. Please, if you have not subscribed to this channel, subscribe. Then share the video. Give me thumbs up so you can encourage me to do more of these videos. Please share the videos. Thank you very much. You take very good care of yourselves. We are going to meet again in our next video. Bye.